Welcome back. Today we are going to be talking about a function functions that are called piecewise functions, and they're a little different than what we're normally used to. So a piecewise function is a lot like what the name would imply, which is that it's a function that goes in pieces. So basically it's a function that has different rules for different values of x, or values of the domain. Now, to evaluate, so what it looks like is it looks like this. So it says f of x is equal to some function here if x is within a certain range. So it's equal to negative x if x is less than 0, or x plus 1 if x is greater than or equal to 0. So depending on the values in the domain, these are the domain values, right? The values that we're inputting, the output rule is going to be determined by different values of the domain. All right. Now, to evaluate a piecewise function for a given value of x, what you want to do is you want to determine, when you're substituting this in, you want to determine which rule applies. So by that, okay, you want to figure out which of the parts of the domain it applies to. So let me take this out so we can see. If we're looking at the piecewise function here, and we're trying to determine f of negative 3 and then separately f of 4 and all the rest of the values here, what you do is you determine which of the domain parts it's in. So f of negative 3, okay, so negative 3 is less than 0. So what we're going to be using for this one is the top rule. Okay, so f of negative 3, what does this rule say? It just says take the opposite of the input, right? This is, it says negative x, but really, theoretically, what that's doing is it's whatever the input is, whatever x is, you're taking the opposite. So it would be negative 3, which is 3. So f of negative 3 is just 3. Okay. Now f of 4 is a little different because it's going by the bottom rule, because 4 is greater than or equal to 0, right? So it's in the rule for the second part of the domain. Now all this rule is saying is just take the input and add 1. So this is just 4 plus 1, which is 5. So f of 4 is equal to 5. Okay. Now f of 0.2. Okay, so let's think about it. 0.2 is greater than or equal to 0. So all we're doing here is we're taking 0.2 and adding 1 to it to get 1.2. So f of 0.2 is equal to 1.2. Okay, and then finally f of 0. Okay, now this is kind of tricky because the piecewise function is 0 is the dividing line between the pieces of the piecewise function. So is 0 less than 0? No, 0 is greater than or equal to 0. So we are going to be using the bottom rule here, because that's where the domain value of 0 fits in. So we're just going 0 plus 1, which is 1, so f of 0 is 1. So all a piecewise function is it's just like a function that's split into different parts. Sometimes there's 2 parts, sometimes there's 3 or 4. Complicated ones that you might see in Algebra 2 might involve more than 4 parts. But all you're really just doing is determining which function rule you're using based on the value of x that you want to determine. Okay, when you graph piecewise functions, what you want to do is you first of all think about the dividing line. Here the dividing line is x is 0, and that's going to be the y-axis, right? The equation for the y-axis is x is equal to 0. So here we have a rule that goes up to x is equal to 0, and then a rule beyond that. So let's just think about the negative values of x here. So let's see. Let's determine negative 4, negative 3, negative 2, negative 1, and 0. Actually, let's just determine a few of them, like this. Okay. So at negative 4, it's taking the opposite, so it's 4. At negative 3, it's taking the opposite, so it's 3. At negative 2 again, like this, and at negative 1 again. Okay, at 0, it jumps to the other function. So 0 starts by taking the input value and adding 1. So this is 1, then this is 2, and 3, and 4. Okay, let's plot these points. So we have negative 4, 4 here, negative 3, 3, negative 2, 2, and negative 1, 1. Now, what I want you to do is I want you to actually think about the value of, under the function rule here, if 0 were defined for this function rule, what would this be? It would just be the value of 0. So what you're going to do is put an open circle here. So just like when we were graphing inequalities, we had an open circle and shading to one part. That's exactly what we're going to do here. We have an open circle at 0, meaning everything right before this value is defined with the function rule here, the top function rule. But everything right up until the x value of 0 is defined. So basically, we're just going to draw this line. I did a poor job doing this, so let me grab my line tool and do it a little bit better. So basically, it's like a ray. It's not a double pointed arrow. It's just a ray, because so a ray has an arrow on one end. It's a double pointed arrow, and sorry, it's a single. It's an arrow. It's a line with a single arrowhead, which is called a ray, starting out from the origin. Now, what ends up happening is this other function rule, so 0, 1, here we're going to have a closed circle. So at 0, 1, closed circle, we have 1, 2 right here, 2, 3 right here, and 3, 4. So we know these are both lines, right? They both have an x, the exponent on the x is 1, so they're both lines. So here we have another ray right here going off into this direction, right? So it's a ray with this arrowhead right here. But here, what ends up happening is, since this is an open circle and this is a closed circle, so what you're basically doing is you're getting the values of the function along this line right here, but when you get to 0, you jump up to this point. And that's the value. So the value of the function at 0 jumps from 0, where it was like going towards 0, but it jumps from 0 up to 1. Okay? So basically, sometimes you're given piecewise functions just as graphs. So if it was just given as a graph, you could determine the value of the function based on, like, for instance, if I tried to find f of -7, well, -7 is in this range, so I would say f of -7 is just +7, right? Whereas if I'm trying to find f of 7, well, f of 7 is in this part of the branch, so I would just look at the value of 8, right? F of 7 is 8. Here, f of 0, since that's an open circle there, I would jump up to the value of 1. So at no 2 points you can't have two closed circles that are like if this green circle were closed, and that would be a big problem, because the function, it wouldn't be a function anymore, because a function rule says that it can only be one output value for every input value. So that's why we have to have an open circle here and a closed circle here. Okay, so if you were to draw a piecewise function, this is a little bit more complicated piecewise function here. It's a 3-part piecewise function. And there's 2 hinging values here. -2, so at -2 it jumps from the top value here, and then it goes to x squared. So basically, this function is a constant function. It's a horizontal line up to the output value, or the input value of -2. Then it jumps to a quadratic equation, a parabola, here from between the values of -2 and 2, and then it jumps back into a horizontal line. So it's like a horizontal line, a quadratic parabola, and then another horizontal line. Okay, so let's just figure out for different input values. So f of -2, for instance, well, that's a hinging value. So notice that it's a horizontal line when x is less than 2, but when x is equal to -2, it is x squared. So basically, this goes by the rule, take the input and square it, so f of -2 is 4. F of 3, so 3 is greater than 2, so 3 is just going to be the value, the constant value of 3. So f of 3, because if the input is greater than 2, then it's going to jump to this. Okay, f of 0, well, 0 is in this range, so we're going to go by the rule here, and that just says take the input and square it, which is 0. Okay, that's just a way to determine some of the input values. Now, let's look at the values of -2. So let's graph this. So essentially, you're looking at, until 2, I'm going to put an open circle at -2. I keep saying 2 instead of -2, but I'm going to put an open circle here, and then I'm going to have a horizontal line at 3. So this right here is the value f of x is equal to, whoops, it actually should be -3. So actually, let me just go ahead and bring this whole business down here to -3. Okay, so f of x is equal to negative 3. Then at negative 2, it jumps up into a parabola. So it goes up to a 4 because we just determined that value, right? So that's a big closed circle here. And then at negative 1, it's just a negative 1 squared, which is 1. At 0, it's 0. At 1, it's 1. And at 2, it's 4. And we do include that value because that's the end of this range right here. So basically you have this, and you don't have arrowheads here, it ends here, right? Because it's only defined by this parabola in the domain ranges of negative 2 to 2. Then we jump to 3. So basically we go to an open circle at 2, the value of 2. We have an open circle at 3 right here. And we essentially just draw this horizontal line. It looks a little tricky with this open circle being on this line, but this branch actually should be just to the left of the open circle there. And that's how you would graph this piecewise function. Now, when we talk about the domain, well, what are the values that this function is defined on, the input values? Well, basically every input value is covered. It's just the pieces of it are covered. So here the domain is all real numbers. I'm allowed to put any value of x in here. The range is a little trickier. Now the range here, if you think about it, the range goes from, well, it includes the value of negative 3 because at certain points it's negative 3. It also includes the value of 3. Then it includes the value of all real numbers between 4 and 0. So it's 3, we'll just do it like this. Let me just list it out instead of using set notation. It's negative 3 and 3, so it's defined on those two. And then all real numbers between 0 and 4. Okay, so essentially like it jumps down to negative 3 when x goes very negative, it goes to negative 3. When x goes very positive, it goes to 3. But then it also includes all these numbers in between. Remember, these are tiny little, all these points are like, it captures all the x values between, in this range right here, of 4 to 0. So it captures all those values, and then it also captures all the x values of 3. So I guess all real numbers between 0 and 4 include 3. So I don't even need to include that. So it would be negative 3 and also all real numbers between 0 and 4. Okay, if we were given a graph and we had to write a piecewise function from the graph, so essentially look at your hinge value. My value that the two pieces are hinging on is the value of negative, still in my highlighter. Okay, it's the value of negative 1. So here I want to just use that as my breaking point between these two values. So here, notice also that these right here are the brackets that we use for the set notation here. So here, this value right here of this domain value of negative 1 is going to be included on this branch, whereas this one has an open circle, so that's not going to be included. So my first thing is x. All x is less than or equal to negative 1, and my second branch is going to include all x's greater than negative 1. Okay, now let's determine what this line is. If we were to continue this line up, it would have a y-intercept of 2. And let's determine the slope here. The slope is down 1, right 1, down 1, right 1. So the slope is down 1, down 1, left 1. That makes all the difference in the world because the slope is 1. So my equation here is y is equal to 1x plus 2, or y is equal to x plus 2. Now, since my y is essentially my f of x, all I have to include is my expression on the right-hand side here. So f of x is equal to x plus 2 when x is less than or equal to negative 1, and it's equal to, okay, so this is just a constant value of 3 when x is greater than negative 1. Okay, so essentially it's like a diagonal line until the point of negative 1. And I just extended the line here so I could get the y-intercept so that I could tell what this was. But the rule is essentially the same. It's just take the x value. So essentially like here, we would take the x value of negative 4 and add 2 to it to get negative 2. So we have negative 4 here and 1, 2, 3. Whoops. So this is actually mislabeled here. This actually should have been -5. And that would have made, because this is 1, 2, 3, 4, 5 over there. So it'd be -5. So essentially I would take -5, add 2 to it to get 3. And that's where we see the coordinate -5, -3 right here. Okay, so all it's doing is just giving you different rules right here. Now here, so the domain, the domain is pretty simple because this function is defined for all real numbers. I'm allowed to put in any x, or there's nothing that makes this function a problem. There's no, essentially nowhere where you're dividing by 0. So I'm allowed to put in all real numbers here. Now my range is a little tricky. So essentially, let's think about all the values that this gets. Let me clear this out for a minute here. Now, the values of y that it gets, essentially, the function can get, and I'm going to draw on the y-axis, the function can get any value of y, or the output is any value of y that's less than, and I'm going to also include the value of 1. So it from here, because f of -1 is would be equal to 1 right here. So the range is all real numbers less than or equal to +1. Okay, and then after that, so after 1, it jumps up to the value, the constant value of 3. So not only does it get all the real numbers less than or equal to 1, it also gets the constant value of 3. Okay, so it's a little tricky. You'd end up having to write that out. You couldn't use set notation for that, but that's how you would get the range. And that's the end of the lesson for today.